If you were absent on Friday, you need to make up worksheet 11.1, and also we also did a review of factoring. The review of factoring is to get us ready for the next chapter. So does anybody need a copy of the review of factoring worksheet that is due tomorrow? I got one of those? Okay. So, we are going to fill in the last page of your foldable. This is kind of to help you get the spacing that we're going to need. We're going to need to put 6 examples on this page, and the first 2 examples are kind of small, and then these examples are larger. So at the tip-top page of your foldable, write down your change of base formula and your steps for solving a change of base formula, all the way at the top of the blue page. All the way at the top of the blue page. This is your example number 1 and 2. They're going to go way up at the top of the page, right underneath the change of the base formula, because these are examples of the change of base formula. So right underneath the change of the base formula, write this example. This is what you were doing on Friday. So, what base do I want to change it to? Well, I want to change it to base 10, because if I change it to base 10, I can use my calculator on base 10 problems. Right here on my calculator, this log is log base 10. And so that's why I'm changing it to base 10, so I can use my calculator. So the change of base formula says the log of this divided by the log of the old base. You will not get the right answer unless you close the automatic parentheses with your calculator. So you would put log of 100 divided by log base 5. You have to close the automatic parentheses, and the answer is 2.8614. 2.8614. Evaluate means what's the number? Now, what does the number mean? What was the base in our original problem? It means that 5 raised to the 2.8614 power is approximately equal to 100. You believe that? Let's check it out and see. 5 raised to the 2.8614 power is not quite 100. Why is it not quite 100? Because I rounded off. Matter of fact, we need to talk about rounding off. It says in the instructions to round to 4 decimal places. Now, when I was looking at the answers entered into Schoology on Friday, some of the people missed the problems because they didn't round right. So we're not going to have that problem anymore because we're going to let our calculator round for us. So right here next to the yellow button, push the mode button. Even if it's already set, I want you to do it again so you'll know how. And this row right here controls the decimal. And we want it to be round to 4 decimal places. So we highlight the 4 and then push enter. The mode, this row right here, controls the decimal. And so the calculator is going to round off for us when we set the mode to 4. Okay, next problem. The log of 85 divided by the log of 2. These logs are base 10 because when the base is not written, the base is 10. The reason I'm changing to base 10 is so that I can use my calculator, because this log button on my calculator is in base 10. So That's the answer. 64094. 6.4094. What does the answer mean? What was the original base? 2 raised to the 6.4094 is going to be approximately equal to 85. That's what you're finding when you're finding a log. What was the exponent to get that number? Now, we can use this change of base formula to help us solve some problems. Now, you see on the top of the screen, don't write this down, but I wanted to draw your attention to these two kind of problems. They almost look the same, but what's the difference? What is the base here? X. So to solve for X, you have to get rid of the power. You would do that by raising it to the reciprocal power, and X would be whatever that is that you would calculate out with your calculator. But on this other one, X is not the base, X is the exponent. To solve this kind of problem, we have to get the X out of the exponent. How? Let me show you. Write down example number 3 in your notes. It may be on the bottom of the blue paper or down in the green paper. To solve when the exponent is the X, you take the log of both sides of the equation. Whatever you do to the left-hand side of the equation, you have to do the same thing to the right-hand side of the equation. Now, why did I want to do this? So that I could use the power rule. The power rule says this X comes out in front. The X is not an exponent anymore. So now I can solve for that. The log of 18 simply represents a decimal number, and so I can divide by the log of 18. If I divide the left-hand side by log of 18, I have to divide the right-hand side. And so this can go in my calculator as long as I remember to put the parentheses around both of my numbers there. If you leave out the parentheses, you will not have the right answer. Okay, let me double check. Let's see. Log of 44, close parentheses, log of 18, close parentheses. Is that what you got? Okay. Good. Now, would you please look at your blue homework paper? Can you do problem number 1 on your blue homework paper? We are going to take the log of both sides. The reason you take the log is so you can use the power rule and bring the X out in front. To solve for the X, I need to divide by the log of 16. You put it in your calculator. You have your calculator set to round off. So I should see more than just an answer. Now, there are maybe a few steps you could skip. on some of these longer problems. Would you please go back to your foldable notes and put this example number 4 in your foldable notes. As you can see, this is a little bit more complicated. So what you have to start with is isolating the base. 8 is the base. How do we know 8 is the base? What? It has the exponent. That's why it's the base. And so we need to isolate it. So what are we going to do with the 10? Subtract 10 from both sides. We're going to subtract the 10 from both sides to isolate the base. Then we're going to take the log of both sides. The reason you take the log is to bring the exponent out in front using the power rule. I am solving for the x. So I am going to cancel out the log of 8. I'm going to put the log of 3 divided by the log of 8 in my calculator. I'm solving for x. What am I going to do with the 4? Divide by 4, and x equals 0.1321. Do you have a question? Example number 5. You start by isolating the base. The 6 is the base because it has the exponent. To solve, I need to isolate the base. So what am I going to do with the 15? Then to solve, you take the log of both sides. The reason you take the log of both sides is so that this can come out in front using the power rule. This x plus 5 is the exponent. It should have a parenthesis around it because it's grouped together because it was both of those were the exponent. Divide the log of 70 divided by the log of 6. What am I going to do with the plus 5? One more example. You have room for one more example? Wait just a minute. Some people are finishing up this example. Isolate the base. The 4 out in front is multiplied by the base. What is the opposite of multiply? Then, oh, what happened to the negative signs? Over here. Negative divided by a negative cancels out and makes positive. Take the log of both sides. The reason you take the log of both sides is so that this can come out in front using the power rule, and now it's not an exponent anymore. Divide by the log of 2. Log of 9.5 close parentheses divided by log of 2 comes out to be this decimal number. I'm solving for x, so what am I going to do with the 5? You could check by plugging the number back into the original problem.